Alright, that worked. And close this. Hide. Alright guys, so this is our only geometry class, I think. So it's like the algebra and NT. We're just going to cover one topic instead of covering all of them like we did for the three combo classes, or counting and probability classes. So I just picked circle geometry because there's multiple things I could have chosen. I could have chosen just non-circle geometry, like with triangles and stuff. There's also 3D geometry, but yeah. Okay, I guess we'll just get started with basic formulas about circles, which you should hopefully know. Alright. So this is a circle. Hopefully you guys know that. This is the radius. This is the that's not the diameter. That's the diameter. Yeah, floor of pi equals 3. So pi is like 3 point something. No one knows what's after it. Yeah, 3.14, etc. The circumference is 2 pi r. The area is pi r squared. Things you hopefully know. So yeah, hopefully we have no questions about that. And all types of geometry are related. So we're going to have to know some other formulas as well, because you can't just do only circle geometry. So let's go over these. Again, hopefully you should know most of these, but yeah, it looks like you guys are doing a pi recitation contest. I don't even know if that's pronounced correctly. Let's see how many I can do. 3.1459265358979333846. I don't know. Is that right? I don't know. I memorized it like a long time ago and never did more. Anyway, yeah, there we go. There's a person that definitely memorized all those digits. Okay, so Pythagorean theorem. If it's a right triangle with legs A and B and hypotenuse C, you get the formula a squared plus b squared equals c squared. The area of a triangle is half base times height. The area of a rectangle is length times width. Yeah, half a b sine c. I guess we can also go over Heron's formula. Yeah. We're not going to go over the trig formula because trig is not supposed to show up in math counts. And if s equals a plus b plus c, I can't draw the c, over 2, then a equals root s minus a, s minus b, s minus c. So if you just know the side lengths, then there it is. Yeah, let's not go over that because you don't even need it for like Amy. No. You can post in the chat if you want. Special right triangles. This is the only form of like kind of trigonometry that you'll have to know, but it's not really trigonometry. If it's a 45, 45, 90 triangle, you get 1, 1, root 2 as the side lengths. 30, 60, 90, you get root 3, 2, and 1. These are the side length ratios. So usually you won't get any other angles like 36 degrees or 15 degrees. Usually these are the only ones you have to know. And similar triangles, there's similar ways to prove similarity: SAS, ASA, AA, and then SSS, similarity. And if two triangles are similar, you can have like all the side ratios and equal angles and stuff. And other angle formulas, for example, if this is a thing, then this. Okay, if these are parallel, then this angle equals this angle. Just review. We're not going over Chapa's because we might if it was not circle geometry, but we don't really need it for circle geometry. I'd say Chapa's is too hard though. Chapa's is an AMC. Yeah. It could probably be in the late AMC problem, but I mean, I think it may actually be a little advanced for math counts, and it's not in this class, so it can be enhanced. Okay, but unfortunately, we don't have time to cover that. Maybe like target 8. I don't think target 8 at Nats would be something like just application of Chevas. It would just be like some random problem. Okay, anyway, any questions about this stuff? You had to prove it. That's not good. Proving it's hard. Anyway. Alright, looks like no questions. Mandelbrot set. What? Alright, so far we haven't covered any like specifically like circle geometry formulas except for like area and like perimeter or circumference. But we can still do a few problems with this, just with this information. And a lot of geometry problems, like honestly, they're like you have to like find clever methods to do them and stuff. So yeah, I don't know if you call them lazy. I think at least 20 miles away. Wow. Yeah. So okay, I guess you guys can try this problem. There's a house, and he wishes to run at least 10 feet away. Alright, looks like we have 280 plus 20 pi. Yeah. I'll let other people try it first, though. 360 is a little suspicious. Yeah, so this is circle geometry, so there's going to be circles. Sigma and k equals 2. What? Where does k come in? I don't know what you're doing. Alright. So, okay. So the path is something like this. Normally they would probably like give you a diagram. I didn't word this very well. So it'd be you'd run along the wall of the house 10 feet away, and then you would turn like that, and it would be a circle because you always stay 10 feet away from the corner, and then this, and then you turn there, and then turn there, and then you turn. Yeah. So if you want to find the perimeter or the distance of this path, you can do the straight lengths. Didn't count down or something. All right, point system. Whoever gets the most points wins or something. So if you look at the perimeter of the straight lengths, like if you add these green lengths up, it's just the perimeter of the rectangle. So then you get 60 plus 80, I'll just write times 2, equals 280. And almost always in these problems, the circular parts should become a full circle. You should probably check this always, but you don't have to like do 4 times a quarter circle. You can just do 2 pi r, which is 20 pi. So our answer is 280 plus 20 pi. Alright, any questions? Alright, let's go on to the second question. I already drew the diagram for it. What is land? Yeah, you can't go in the doghouse, I guess. That should probably be specified, my bad. Actually, yeah, that's actually not very specified. Dogs should stay outside, and you can't go inside. Yeah, maybe. Alright. Okay. Any ideas, thoughts? Okay. Any thoughts relevant to the problem? He's not tied forever. He just might be there while someone, yeah. What should the area of the land look like? Maybe. You need paper. All right. Okay. So if you try drawing the area, first you have to be within 6 meters. It's going to be this part of a circle here. That's not really a circle, but yeah, drawing is hard. So this is a circle with radius 6, but you can also go to some other places. Where else can you go? Cradle latex dock. Why? Yeah. So you can, of course, if the dog is here, you can curve over, and it becomes curved like that. But if you think about it, let's say there's a corner and the dog is like, the leash is this way. You have to like turn, and then you have to pivot, you have to pivot from this vertex. So these parts of the circle, this part of the land actually has a radius of 2 instead of a radius of 6, because you can't like go, the leash can't go through the doghouse. So if you calculate the area, this is 2/3 of a circle. So 2/3 times pi r squared, which is 36 pi. This part is 1/6. Let's see, 1/6 of 4 pi, which is pi r squared. This is also 1/6 times 4 pi, and you can add these up to get the answer. Yeah, I don't want to calculate it. I guess it's 24 pi plus 4/3 pi, so something 76 over 3 pi, something like that. No, that doesn't seem right. Actually, it does. Yeah, maybe not the best numbers, but whatever. Any questions? All right. Next. And just feel free to ask questions anytime, because I can always go back. Should I have the side of 3? Yeah, that would have made the numbers easier, but whatever. It doesn't really matter. Let's see, let me actually join the other class in Google Calendar and see if it's like anyone's in that class or whatever. I'm just gonna see. Alright. Let me switch account. Let's see, 3√6. That makes sense. All right. Let me just check no one's in the other class. I guess no one's in the other class, so I don't know. Looks okay. All right. Nice square root. So yeah, the radius. Okay, so hopefully most of you guys have tried this problem. OD is the radius, yeah. OD is the radius. And it's a diagonal of a square, so that creates a 45, 45, 90 triangle. So then you get, this is 3√2, 3√2. So then you get CO is 3√2, and you get AC squared equals 6 squared plus 3√2 squared which becomes 54. So AC equals 3 root 6. Any questions? All right. The second question I drew in MS Paint. So, yeah. Besides the point. Yeah. The second question is a bit harder. Is it not really? All right, maybe. Depends on how you look at it. I mean, I think it's harder than the first one for sure. Any ideas? Can't see because of the bar at the bottom. I think if you click the screen, it should do something. I don't know. I mean, for me, it's like far above. Like even with the bar on the bottom, it's still. Yeah. Okay. So this shape is obviously not like a basic triangle, a circle or anything. I guess I'll give more time. Yeah, you guys can spend more time. And yeah, 40 is correct. Yeah. So it's a nice problem. Turns out interesting. Yeah. I mean, if it just doesn't say in terms of pi, I guess you can like engineer the answer somehow, whatever. All right. So, any ideas on how to start the problem? I know you guys like did it, but well, that will say common fraction in terms of pi. Anyway, so this gray area is not like a basic shape like a circle, so you're gonna have to add and subtract areas to find it. So let's consider this shape, which seems like the basis to start on. So the area of this shape is 40 plus. So it's the rectangle. Let's say the rectangle. Let's not actually find the areas. Plus the semicircle. Sprint or target? It's just some other problem. It could be countdown, I guess. I don't know. And what do we have to subtract from it? We have to subtract the thing in blue here. I'm going to draw it in blue. This part here. And the part in green, which I'll draw here. So then you have to subtract this part and this part. That's actually not to scale. Guess is 2 plus 3, 2 to the 3. Why would you guess that? I mean, you could guess like 10 times 4. Okay, so something interesting you'll observe is if we put the green and blue things together, and let's say we move this green thing over here, then they're actually the same. 2 looks longer than 3. It does. You're not wrong. But, I mean, whatever. So, if you move this thing over here, if you look at actually these is just, when added together, the sum of these two areas is actually the semicircle. The same thing. I can't asymptote arcs. Also the shaded area, come on. It's more better. Yeah, it's more better than your English. That's... What? How is my English? It's not hard to have better English than your sentence there. Alright. So these cancel out, and you're left with the area of the rectangle. If you see, the rectangle has a length of 10, and the height is 4 because you have a 3, 4, 5 triangle. Actually, we should have gone over Pythagorean triples, but whatever. You get a 3, 4, 5 triangle here. Let me draw that better here. So you get, this is 4, and the area is 40. Wow. Chat is interesting today. Alright, any questions about that? I'll take no U as a no, because no U contains no. Alright, looks like we had an unused blank piece of paper thing here. Alright. Alright, some more questions. What is that? Why is 64 equal to 65? Schoology is up, yeah. Okay, this is just, I think you rearrange them, but like not in the right way. It's like slightly off. Also, they're all in Chinese. Alright, let's see. Yeah, those slopes are, you know, not right. One of them's 2/5, one of them's like 3/7, which are, you know, slightly off. That is an ellipse, but that's only because Jamboard stretches it and stuff. You have friends? What? Alright, so the first thing is just kind of, I guess, something to know instead of like a problem, really. So you can subtract areas and get the area of the big circle is pi r squared with a big R, and the area of the small circle is pi r squared. So that's the answer to the first part. Do we have space in the next page? We don't. I guess we'll go to the previous page. Yeah, so if you see, D is actually the square root of r squared minus r squared by Pythagorean theorem. So this is actually just pi d squared. Just, you know, something to know, I guess. Yeah, this next problem is actually that one that was going to be on the math team test, and if you guys are, you know, from Bolin. But we did not put it on there because it was like, apparently Alex taught it like last year or something, so here's a, you know, scrapped problem. And now you get why he's called Martin de Martian. Yeah, I think. What school? Troy High? Yeah. 49 pi. 49? I don't know about 49. I think it's not 49 pi. I will see, I guess. I'll draw the diagram on the next previous page. Okay. I actually forgot the directions. East 8, west, east 6, west 8, or north 12. Yeah, it looks like you wouldn't have made the team if this was on the test, so that sucks. Alright, so I forgot the numbers already. East 6. So it's basically find the area of this circle. Yeah, he's not in the center. I mean, then you can't go 6 right and 8 left, obviously. Oh, center axis. I mean, okay, whatever. It's low quality? How is this low quality? I think it's pretty good. Alright, any ideas? Power of point and circumcenter of the triangle. Those are the two solutions I was going to show. So nice. So yeah. I guess we'll do the power of the point way. That's really the main way, I guess. So, and this is much easier. Actually, we didn't learn power of point yet. Why is this here? Alright, this is like PowerPoint's going to be on one of the later slides, so I guess this is bad ordering by me. But okay. Power of point states that this length times this length equals this length times this length. You probably have no idea what I just did, but you get 12 times x, where this is x, equals 8 times 6. So x equals 4. This is from PowerPoint. We'll go over it later. Shortlist, we do have the problems, but we're not going to show you them because most of them are going to be on the test. So, yeah. So, yeah, this is 4. And if you consider the center, you'll see that this is like the center. This is the... you're going to get a preview. This point down here is the midpoint of the chord. So that means this has to be 7, 1, and then 6. This has to be 4 if you try it out. And then you can either get, this is root 7 squared plus 4 squared, or this is root 8 squared plus 1 squared. And both of these become 65 pi. So another solution we saw, I guess we won't go over too much, was, it was the circumcenter of a triangle. And if you consider this as a triangle and you find the circumradius, you can do that. It's 8, 6, 12. The formula is the area is the product of the side lengths over 4 times the circumradius. Or you can flip the radius and area if you want. 4a, yeah, you can put r equals abc over 4a. And it's not that hard to find each of the side lengths, it's just Pythagorean theorem. And the area is also pretty clear because the base and height are given. So this method also works. It's not much slower. Arguably almost the same. But yeah. It's easier to see, a little harder to actually do, but I mean, if there's a choice. It's a good problem unless Alex spoiled it last year. Alright, any questions? Yes, what is your question? We did not. We started like a few days ago. Yeah. Okay, so let me actually go to the length formulas. I have PowerPoint here. I guess we'll go over it right now before doing the angle formulas. So for any point P, whether it's inside or outside, if you draw two lines, then you get PA times PD equals PB times PC. Even if there's a tangent, I just didn't include tangent because I was bored. You can kind of consider this as like a double point. So this is, let's say, x and y. So this also equals px times py, which is just px squared. And the important thing to remember is that it's PA times PD always. I did. I just found them randomly off the internet. So it's always PA times PD. It's common that if you're outside, you kind of often do like if it's PA and D, you kind of sometimes do PA times AD. We've all done that, I think. So just don't do that. It's not. It's a pretty easy mistake to make. Actually, like when I was doing one of the problems that I made, that I put in here, I was like, "Why is this wrong?" Because I was, doing it wrong. We'll go over Ptolemy's later, or Ptolemy's, I guess it's silent. Very professional. Ptolemy, yeah. All right, so circle angle formulas. These are also very high quality images. Alright, so in a cyclic quadrilateral, which is a quadrilateral with a circle circumscribed in it, you get this angle equals this angle. So from the chord BC, if you extend like an angle this way and an angle this way, they're going to be equal. Yeah, I mean, this is obviously a very, very common thing. It's like one of the most, notable formulas in geometry, I guess, after Pythagorean theorem or something. I guess I won't do red. And another angle formula is opposite angles add up to 180 degrees. So you can almost see this as if you have a thing in a circle, if you have like a chord, if you go this way and you go this way, they're going to be adding up to 180 instead of being equal, because you're going to the other side. So yeah. What are you doing? Alright, chat's suspicious today. Additional formulas. So if you have something like this, you get that this angle is 100 minus 30 over 2. So the length of this, the what do you call it? The length of that arc minus the length of that arc over 2, where this is the length of the arc. That's how it's defined. Yeah, I didn't show the one in the center. I'll draw that in after I'm done. I don't know if that's what you're talking about. Yeah, BOD. Yeah. And if they intersect inside the circle, then you add them up and divide by 2 to find the angle. These two aren't the most important, but they're important, I guess. Yeah, I'll show it right now, I guess. If you have a triangle and you have the center, not a triangle, a circle, and you have the center, and you have like something like this, then you have this angle over here is exactly half of that angle here. So if this is x, let me do it in red. If this is x, this is 2x. I just forgot to put it on here. That's an important one too. And finally, down here, if there's a tangent, if there's like, let's see, this is the way I memorize it. If there's a tangent and then it curves in like this, the angle formed is equal to the angle formed by that. So I guess it's just this here. It's equal to the angle formed by that chord. So in this diagram, the two blue angles are equal. Is that intuitive? Is it? I don't know. I don't have much geometry intuition, so maybe it's intuitive to you. I don't know. Well, these slides will be posted, yeah. Hopefully quicker than last week because last week I just kind of waited. Um, the YouTube videos sometimes take a very long time to upload. For some reason, I don't know. It takes like 6 hours to upload a 1 hour video, which is kind of slow. Are any questions about these formulas? Yeah, 6 hours. I don't know if that's short enough. Honestly, it's probably like 8. All right. I guess we'll go to some problems. Can't draw. There we go. Nice angle sign ripoff. Yeah. I don't want to copy angle signs, so that's close enough. What do you want? It's a free class. Come on. What did you expect? You should be happy that I'm not giving you viruses. You're getting free stuff off the internet. Come on. Copy paste from the web. Sure. Am I now? Yeah, I guess. I forgot what I said before, so I don't know what you're actually responding to. Any ideas? 114? I don't know. I have to do the math. That's kind of not my strong suit. Let's see. 102. 38. 102. What is why are you spamming in the chat? Come on. 114? When I'm finding RQV, let's see. Alright, any ideas though? I don't know. I don't know about 114. 102? I don't know about 102 either. I think it's smaller. Wait, I mean, let's see, I guess. I don't know. You guys might be right. Alright, what's the first step, guys? VS is 36, yeah. So, I guess it's 72. But anyway, what we have to use is VRS equals VUS because they're from the same arc. So this is also 36. What other angles can you find? VQS? Really? What? Wait. How? Since I know VS. Oh yeah, that's true. RU minus VS equals 42. Yeah. Yeah, that's the way to do it. I guess. I didn't see that. I think my way's a little easier though. Anyway, I guess we'll go with Michael's method then. By formulas before, we get RU, the arc, minus VS over 2 equals 42. And we get RU plus VS over 2 equals, what is it? Equals VQS. So that means if you add if you like subtract these or whatever, you get VQS equals 42 plus VS, the arc, which equals 42 plus 72. And it's 72 because you have to go to the center here, and that's 72 by double angle things, which equals 114 degrees. That's where you got the 114 from. That makes sense. And then to find RQV, you take 180 degrees minus 114 degrees equals something, 66. Yep. The method I was thinking was just in this triangle. Let me do it in green. Did I forget times 2? Oh, you forgot times 2. Okay. So in this triangle here in green, hopefully you can see it, you can just find the third angle because they sum to 180. So this is 180 minus 36 minus 42, which equals 102. 102. And now RVQ, which is, maybe a little hard to see. Let me try doing it in yellow. That's probably harder to see. So RVS equals 180 minus 102 equals 78. And then you get RQV. Hopefully we have another slide. We don't. That sucks. Whatever. And you get RQV from the other angle. So you get, let me do it up here in the top left. Hopefully you can see that. RQV equals 180 minus 36 minus 78, which equals something, 66 like before. So yeah, I thought that was easier, but whatever. Alright, any questions? Multiple ways to do it, but whatever. If so, we can try the second problem. Ptolemies. We didn't learn Ptolemies yet. I mean, I know we used power of a point before we learned it, but we were not going to use Ptolemies before we learned it. I don't think any of the problems here actually use Ptolemies, because I just didn't have any questions. I don't know. We'll see. BD is 23. Well, Ptolemies is, when is Ptolemies used? In cyclic. Is this quadrilateral cyclic? Yes? What? Okay, let me label in the lengths first. This is 10. That's 16. 10, that's still 16. 10, 10, 10, and 10. So what interesting like circle observation can you make? 80 is 13. Yeah, I'll write that in. That's true. ABC is equilateral, so that means the angles are all 60 degrees. Can you find any circle to draw? ACD is isosceles, yep. BCD is also isosceles, yeah. Can you find a circle somewhere, somehow? Some type of circle. It may not be the most intuitive, but ABD. Yeah. If you let's draw the circle of ABD. What's special about the circle of ABD? Whoa. Is my screen gone? Rip. Okay. That's fine. It's not bad. Where'd it go? Hello? I was literally screen recording. I crashed. What? I'm back? What? What's going on? Okay. Looks like the app crashed. Enter a meeting code. Actually rejoin the class. Is there two of me in the class now? Wow. Present screen. Start broadcast. And Jamboard crashed. There we go. Let's go back to the problem that we were on. Or anything special about ABD? Oh no, my device is infected by COVID. Yeah, so the reason why you draw this circle is because from C, each of these radii are 10, or they're not radii yet, but all of these lengths are 10. So that means the circle is centered at C. And the radius is 10. Alright, yeah, I guess my other me left somehow. Okay, so how can we find angle ADB now? Yeah, so ADB equals angle ACB because C is the center. And we know ACB is equilateral, so we get 30 degrees. Yeah, whatever. Whoa, I almost just deleted the whole slide. Alright. Yeah, I can move this image around. There you go. Alright, so yeah, the 13 we didn't even need. Any questions? That's not a question. That's not, no. Alright, yeah, this class is recorded and will be uploaded hopefully today or tomorrow, but probably in like a half a year. Knowing how I work. Anyway, yeah. Bye. Alright. So, length formulas. Power of point we already went over. Alright, bye. So, yeah. Power of point we went over, and now Ptolemy's theorem. I think it's Ptolemy's. AB times CD plus AD times BC, or BC times DA, equals AC times BD. So hopefully you see how it's relatively easy to memorize. Yeah, I skipped forward for the power of point and then went back, so. Yeah, but let's see. CYXT, I messed it up. ZYX, WTS, or QP, ONML, KGIH, GFED, CBA. Okay, whatever. Alright, so no questions, hopefully. I don't think we'll use that here, but just for you guys to know. Let's try some questions. These may actually be becoming harder now. I actually have a ton of questions, so yeah. Big gray circle. What? I don't know what you're talking about. That's just you having your mouse on the screen. That's just your fault. Yeah. Alright, okay, I guess I'll let you guys work on number 1 for a bit. Actually, I'll make this bigger. Bam. That's better. Actually, no, it's not. There we go, similarity. Actually, I'll draw in the side lengths. AB is 8, AP is 2, PC is 4. Mass points. Maybe. Maybe. Alright. I wouldn't use mass points. I don't know if it works, but it's not much to scale. So yeah, I see CD equals 1 4 times by the same person. Because this is power of point, you just pick the point P. So you get 2 times 10, make sure you have to do 2 times 8, equals 4 times 4 plus x, or 4 plus something. And you get something as 1 because they both equal 20. Alright, now what? Just subtract. Yeah, you could do that, yeah. So, yeah. Let's let the areas be... Let's let this area be x. What other area can you find in terms of x? ABE, which is PAD. Yeah, this is 64x. What's the area of PAD in terms of x? What's the area of PCB in terms of x? I'm not sure. I don't think you can directly find it. 100x? Okay, the problem is right now... Okay, so the reason why CED and... the reason we found the 1 to 64 ratio here is because if we have similar triangles, we have this angle... This triangle is actually similar to this triangle. And that's how we found the 64x, because 1 and 8 are the corresponding sides. And we actually see that BAE, let's try this. Triangle BAE is similar to triangle BCP. However, the corresponding sides to that are not 8 and 10, because those are actually the opposite. Squeaking sounds are interesting. Ignore them. Yeah, it's flipped over, so we can't actually use similarity. Any other ideas? But the 64x is correct right now. PAD, how would you find PAD? Is 25x. Squeaking sounds. I don't hear big squeaking sounds. There's a fan right now, but whatever. Yeah, BAE and ECD are similar. Remember the angle formulas we had? We actually get BAE equals BCD. And then you can correspond all the angles to each other. Alright, alright. Come on. Let's mute you. Mute. Can you don't? So yeah. Hopefully that answers your question. Actually, yeah. Wait, are BAE and BCP even similar? They are. Yeah. Yeah, makes sense. Yeah. Anyway, so what we're going to use here is let this the area of the quadrilateral be y. So we have BPC is actually similar to PAD. I mean PBC equals PDA. You could draw BD. I mean, you could. I think I'm going to go with this though. So we actually get PAD is similar to PCB, the triangles. And the ratio is 1 to 2. Does this make sense? We actually get two similar angles because PBC equals PDA. So that means if we do the ratio of the areas, it should be 1 to 4. So the areas are x plus y over x plus 64x plus y equals 1 over 4. And from here you get 3x equals 60. So x equals, actually no, that's not it. What am I writing? 3y equals 60x. Yeah, so yeah, that's better. Y equals 20x, yeah. And from here you can find the ratio, right? You get y over, what you want to find is y over 64x equals 20 over 64 equals 5 over 16. I probably went too fast for that, so feel free to ask any questions. Yeah. So they're just a bunch of similar triangles. Make sure you don't confuse the. Yeah, what is your question? You have to figure out the similar triangles in this question because there are a lot of similar triangles and there's equal angles, and yeah, and then you have to figure out what's going on and stuff. Just make sure not to. No, not the stick. Okay. Alright, I guess we'll go to the next question, except I won't. 4, 5, let's see, 4, 5, 8, 11. Alright, let's do it on the next page. That's pretty to scale. I like that. 4, 5, 8, and 11. Find the area of XAB. Yeah, I don't actually use Ptolemy's in any of the theorems, in any of the problems, I think. You don't have to use Ptolemy's every time you cyclic. Yeah. 1/4 area ratio. Okay, yeah. So, what you found is, because of the quadrilateral angles being 180, they add 180. That means this angle is equal to this angle. The red angles are equal. So that means XAB is similar to XCD with a ratio of 1 to 2. 4 to 8, which is 1 to 2. I draw neat? I don't know if this is really neat. Wait, what you say? What are you doing? Oh, I'm using an iPad, so access denied. Alright, anyway. Yeah, there we go. XB equals X, XA equals Y. That's a good thing to do. Now we have two variables to figure out. So can we find two equations? Yes. Can we write the equations? Any one of them. Side length is not very specific. Yeah, I guess, yeah. XAB is similar to XCD. So do you see how the red angles are equal? Because opposite angles in a quadrilateral add to 180. And then XAB is 180 minus BAD, which is equal to BCD. And then obviously angle X equals angle X. So yeah. So yeah, I see both equations here. Feel free to continue asking if you need to. Okay, so from the similarity, we get that x plus 11 over y. Is that it? X plus, yeah, equals 2. Actually, do we have... Yeah, actually I was thinking you need power of a point, but actually you don't. So you can also get, from the other thing, you get y plus 5 over x equals 2. You can also get x times x plus 11 equals y times y plus 5. And that's just a result of multiplying these two equations together. Actually, it turns out like these two equations are simpler. I thought we would need PowerPoint. I guess we don't. So yeah, x plus 11 equals 2y. Y plus 5 equals 2x. And then substitution. Anyone want to do that? Because I don't. Oh, you could subtract as well or cancel. You could substitute, you could eliminate, whatever. Basic, two variable, two equation stuff. I'm getting y equals 9, x equals 7. That seems right. And actually from here, we would proceed with which formula? Yeah, Heron's formula. It is probably the best. That's actually why I taught it before, because I realized we never actually did it. So that means semi-perimeter is 10, which is 4 plus 9 plus 7 over 2 equals 10. So area equals root 10 times 1 times 3 times 6, which equals 6 root... Actually, what's going on? There we go. 6 root 5? Nice, yeah. 1, 3, 6, 10. That's interesting, yeah. I don't know how interesting. I guess it's kind of interesting. 1 plus 3 plus 6 has to equal 10. And that's the answer. Yeah. I guess we're over time already. And I guess all I really have from here is like a bunch of questions. I have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more questions. So we're gonna go over all of them today. Not really. Unless you really want to. So I guess, these can all be homework if you want. It's a lot of homework, but whatever. No homework. What? Bye. No. Yeah. Do you guys want to continue? I don't, sure. Free food? What? You're not getting free food. Unless you want to be affected by COVID. Also, we don't have enough COVID-themed questions on math team test yet. Darn. We should add more, just random COVID questions. Alright, what? In the town of Koval. Alright, I'll start a question like that, sure. Do you guys want to continue? You guys can leave if you want. No, that sounds like a dumb problem. I'm not starting a sentence with that. You're staying. Okay. Then do the question, I guess. We're leaving at 6:30 though. We're not going over 6:30. $6:30 a.m. Maybe if you live in China. I think that's 12 hours offset, right? I forgot. Yeah, alright. 6:30 a.m. in China, sure. Yeah, that's not the best question. You should you should try a bit. That's not. You know. Also, now that you spoiled it, I can't really put it on the test. Not that it would have. Also, 6 people a day is really slow. Find the value of e to the x. What? 6 people per person. I guess that makes sense. Also, it's kind of boring. Code it? Why would I code that? What? Am I coding the multiplication or the spreading? Alright, you guys want to do the problem or not? Alright. Alright, he left. Okay, I guess we can see that the radii are equal. Yeah, it's just the people from bowling. If you look on mathcounts.org, actually, they're saying they're allowing up to 15 people to chapter. So that means we'll probably have at least 15 people, probably like 16 or 17 on the team. It's 20. It's not 20, it's 15. No? BD is 20. Alright. Let's fix that. 20, 20, and 20. ABD lies on circle C. So yeah, this is 60, right? Because it's equilateral. I should draw angles in a different color. This is 60. So this is 120 because it's given here. And now that means C is the center of ABD. So we could continue the circle. Let's not do that. There's no point. And no, we want to find the weird area between the two circles. And how do we do that? We don't. Alright. Anyone? No? Or we're just not going to do it? So, this dumb crescent shape, that's, I'm gonna, banana, whatever, equals 400 pi over 6 minus something else. It's probably right, but I don't know why. Let's see, 100 pi over 3 minus 400 pi something. I don't know about that. Alright, so make sure to subtract the area as well. When you do these type of problems, you have to do that area minus this thing. And then we have to add in this thing here. I believe that's right. And from here, it's just batching areas. 100 pi over 3 minus 400 pi over 6 plus CA is, oh yeah, that's right. Yeah. That's right. So you had 20 here, this is 10. So this length here is something, 2/3 of that, so 20 root 3 over 3. So yeah. Because yeah, it's 30 degree angles and stuff. And then calculate. I don't really want to calculate, but okay. let's see, 400 pi over 9 minus 400 pi over 6 plus something. I think we're getting 2/3 of 100 pi, 100 root 3? 200 root 3 over 2. Let me check the chat after this. No one cares. Yeah. All right. Do you just want to do the last question? I don't want to do more than this question down here. How'd you guys do a chapter, by the way? I don't know. Usually I have like an idea of how good the team is while coming in because of last year's results, but we didn't do state. All right. We won countdown. Yeah. So yeah, that sounds good. Looks like you guys are actually, you guys are gonna have, positive number of people go to Nats. Hopefully. I remember last year we won state, but we didn't actually get any people to qualify, which was weird. Not last year, but 2 years ago. Alright. Let me actually go to another slide and draw it here. And then I forgot the rest of the problem. Like that, and that, and that. A, B, C, D, E, F. Okay. A, B, C, D, E, and F. Alright, any ideas? You got only high schoolers? What? No, don't. No. There are no people from Larson or Smith that are in pre-calc. Come on. Can I see the problem? Oh yeah, I should probably write out all the information. 80 is 24, 17, 17. 24, 17, and 17. And the question asks, find BF? BF. I want to find this length. You have Marley? Wait, you have Marley? What hour? Your fifth hour. Oh, what? Fifth hour? How does that work? What? Wait, that makes no sense. Are they just expecting that we don't go back to school? That doesn't work unless you're virtual. And do you guys have the same time as us? I think we're earlier normally. I don't know. We are earlier? I'm not sure. I recall everyone just has Stratman. I don't think anyone has Marley for pre-calc if you're in middle school. I guess you get a break period and some period you have to do it twice, 2 classes at once. Deanne? What's the last name? Is Deanne the last name? No. Laux. What? You have Laux? I have Laux. Not for pre-calc, obviously, but interesting. Yeah, whatever. Okay, so I guess I'll give you a hint because this question's pretty hard. Try triangles. Try equal angles and stuff. You got it. What? How'd you get it? You have an idea. Okay, what's the idea? I'm assuming you're already typing it in, but whatever. This is all we're given, yeah. Tangents. DA and DB are tangents, but that makes sense. AB and CD is X, okay. So AXC is similar to BXD, okay. Yeah, so I guess I'll do these two equal angles. Can you find any other angles that are equal to these two? And yeah, I see where we're going at, trying to find lengths, but it's really weird to just find BF because it's like weird. This actually is a really weird problem. Can you use like some unusual fact about the circle? Make a center. Why? I don't want to make a center. A, B, C. And radii. I don't want to do that. Yeah, let's not go down the wrong path. It might work, I just don't know if it works. Might as well not. Yeah, so ABC, you mean like the angle? Is it equal? I'm not sure if it is equal. Why would it be equal? It might seem equal, but I'm not sure if it actually is. Yeah. So if we have tangents, what angle equalities can we get? 90 to the center, yeah. What other unusual ones that we covered previously? Power of point, I guess. Sine 90 equals 1. Looks like Michael has a realization though. ABF. ABF? What? Oh, I see what you mean. AEB, yeah. So yeah, what he's saying is, since this is a tangent, then ABF must equal ACB. Let's actually do this with the other tangent. Is there any other tangent thing we can do? DA, yeah. So DAE is equal. So DAE is AE, right? So AE is equal to. So DAE equals ACE, which is really interesting. So this is equal. All right. And now I guess we have something even. Well, okay. That's a theorem, right? DAE. If you draw the angle DAE, like DA is a tangent. So if you have DAE, AE is like the length. So you get A equals ACE. That's how the theorem works. Let me go back. That's not the formula. There we go. So it's the one down here. Oh yeah. I guess this does go through the center. I didn't even look at that. Yeah, it doesn't have to be right. Well, if it's ABC here, right? It can also be like ADC. It doesn't have to go through the center, right? Because those angles are equal. So it can't be just right angles. But I guess the proof does, I guess, involve the right angle. That's the main proof method. But yeah, it can be any angle. Yeah, 90 minus x and then 90 minus 90 minus x. Let me go back to this. And now, this is a really hard step to see. I don't even know how I would see it. Let's draw this circle that goes through D, E, and A. Anything interesting about this circle? DB is tangent. That it seems like DB is tangent. Do you guys see a way to prove that? AF? What? So, I guess so, yeah. So I'll just say the proof, I guess. So, we see this angle here, right? It like goes in. DB is tangent. So it's the angle theorem we just saw, but in reverse. So since DBC is like DBE is like this, I'll do it in yellow. Since this is like an angle here, this is a tangent and then it's an angle. That angle is equal to DAE, and it already is. We already know that. We know these two angles are equal. So by the converse, which also is true, it must be tangent. And now, how do we know dB is 24 because equal tangents have equal lengths. Yeah, this theorem is confusing. Yeah, it requires practice, but I mean, whatever. And now, let's use power of a point to finish. How would we do power of a point? We have to involve f somehow. dB is 24 because equal tangents have equal lengths. I mean, not equal tangents, but like tangents from the same point. Yeah. This is actually pretty hard. I think this is probably not math counts level at all. But whatever. I guess we can finish on a hard question. df dB. How does that work? We need a circle that goes through f and b then, right? I don't see a circle like that. Let's do power of a point from f. FD squared equals, can we guess 12 and be done with it? You can, and you would get it right. So FD squared, I guess, equals FV times FA. Yep. By power of a point on the big blue circle. Can we do anything else with F? The other circle? Yep. Is also equal to FB squared. So that means FD equals FB, and we have FB equals 12. Yeah. Really nice problem, but I mean, I don't know. It's really hard to see. I guess, I mean, this is almost Olympiad level, to be honest. Maybe. Like, would I see this? Maybe. Anyway, yeah, we're running out of time now. So I think this is the last class because summer is over. No, well, I mean, I'll see you guys in math team because you'll definitely make it, especially since there's like four more people or whatever. Last class this semester thingy. Yeah, yeah, yeah. You're gonna miss the test. Yeah, you're not supposed to make the test. Test. We're making the test, and you have to solve the test. Write everything backwards. We should just give the test in reverse order, just like for number one's the hardest. See how long you guys know it take to realize. Just give half the people like forward order, half the people reverse order, and see how long it takes them to realize. And like see how like the scores are different or whatever. And that's something that's curious. Like if in like a real school test, if you had the hardest problem be the bonus, then people might like not solve the bonus. But if you put the bonus in like the real test and then you put some other random question in the bonus, it's actually like worth the same number of points, right? It's like it's not going to like change the results, but it's going to change them psychologically because people are like, I don't want to do the bonus. They're going to like be like, I should be able to do the hard question that's in the main set of problems. Yeah. And I guess good luck on everything, math team stuff. I'll end the recording. Hello on YouTube and bye on YouTube.